what I got on the EE exam.
With Dr. Suleiman?
Yeah, we're in the same section.
Yeah, I keep forgetting that. Yeah, it's terrible.
Yeah, no,
It's absolutely terrible.
let's see. So
I got all of problem 2 and all of problem, I think it was 3.
Never mind. I have a new worst grade is structure. 87.1.
Worst is an 87.
Yeah.
I think my worst was an 85 apart from me because I did so bad in that exam. I got all of problem 2 and all of problem 3. I got all of problem 2 and all of problem 3 right, and then but I think it was either 3 or 4. But I know I got 2 and either 3 or 4. Completely correct, but I did so bad on one and then the other one got 7,500 exam. It's terrible. And I have a 78 in class now.
Yeah, I used.
But other than that, I have like an 87. I think I have like an 87 in this class.
We can at least get it up to an 80 with the net.
Yeah, I put the like right scores and I can get it up to an 82 in the paper.
Okay, welcome back everybody.
But then I was grades too.
My laptop may crash. My laptop may crash. If that happens, I need to switch it to the whiteboard. So thank you.
87 is my lowest. Apart from that freaking easy exam.
I tested before
Prior to that exam, I had
the
like,
crash. It's
96.
working, but never know. I tested in multiple conditions and occasionally it just gives me blue screen.
And then my grades like.
Very unstable. So, good thing is nobody's online today. Great. Because the other section usually 5, 6 people online. Okay. So I'm going to continue using the pen tablet as long as it doesn't crash my laptop. But if it crash happens, I'm going to switch it to whiteboard. Okay. So let me just take the rest of them.
No!
I know who you are.
Tell when you start.
Wait.
I am in DP. I'm checking to make sure there are no updates.
He shows us at the beginning of class, but there are no more updates since the one about cheating.
Yeah, I know, and that was something. I mean, that's like, don't cheat. Something I don't get is because he said he doesn't tolerate cheating. So you think, oh, all the people who cheat get zeros. But yeah, the average on the homeworks, the average on the problem is like an 8, the average on one is like a 9. I mean, the average on one was like a 6. Those averages are really high.
Still,
I mean, it doesn't affect
he would send out that if there was only a couple of people, and that average could still be that high.
I like copying off the check or uploading the which I remember showing some probably
Yeah, that's more so you're paying to like get the experience.
So it's like you're paying more money.
Oh yeah, I can't use tablet anyway because I forgot to bring the tablet. So okay.
Maybe I don't have a subscription.
And then I have no desire to go back to my office. So let's not use tablet. I'm going to use whiteboard, and desktop is going to be shared also. So I'm going to put the desktop my master node, right? So master node is going to show up here. And then I'm going to use the whiteboard probably only this side. Then I'm going to move the camera and try to focus on that. I know it's a poor quality, but at least I can capture something, probably. Let me double check. Because most likely, I don't think I can move back and forth the camera. So anyways, I'm going to do this. Yeah. If I do that, I can actually see myself at the same time the whiteboard. Okay. All right. And yeah, go ahead.
Sorry, just before we started class, I was just wondering if maybe like before or after we could just take a few minutes to talk about the project again?
Yeah,
and
sure.
like a due date?
Yeah, we can do that.
Thank you.
And wait, I'm confused. What am I doing? Am I? Yeah, okay. I'm gonna share the screen. That's right. Okay, good. So nobody's online. So you're looking at my desktop. Go ahead, question. Sorry, could you repeat your question?
Talk a little bit about the test, like
What is test?
exam.
Exam 1?
Yeah, like.
Yeah, sure. Do you have a question for exam 1?
Yeah.
Go ahead.
I just want to know if we're given this formula sheet or not, or if we're allowed to make our own.
What's formula sheet? Formula sheet. What is it?
Like equations.
Equations. Equations will be probably included in problem statement, or you have to derive it from original concept. It depends on the type of the question. It's my decision. Suppose if I provide you equation sheet, yeah, if I feel like it, I'll give it to you. It's part of the problem statement, okay? And then suppose if I expect you to derive an equation, I expect you to derive an equation, giving you like original concept. Okay, start from here, get this equation. But bottom line is, I'm not going to create anything special for exam. Every problem will be taken either from classroom example or homework or quiz or something like that, very similar, because I start from there, cut paste to begin with, then change a little bit. That's my style typically. So I guess the question, this is a very typical question. I don't want you to ask this question to begin with, but this is a question I always get. Do I have to memorize equations? Don't ask me that, because I'm not going to answer that. It's your decision. If you want to memorize, that's the only thing you can do. Go ahead and memorize it. But that's not what I'm asking. I want you to understand everything of an equation which you use. That is higher cost than memorizing. I don't know what it is, but it's memorized kind of thing. I don't care about that. So please don't ask me, do I have to memorize the equation? Please don't do it. I mean, if you know the equation, you don't have to. You can derive it. If you don't know it, the memorization is the only thing you can do. Go ahead and do it if you want to. Go ahead.
For problems such as find the density in a gradient region at a given altitude, will you specify whether we can use the equation we've derived in class, or do you want us to derive from Euler's equation?
It depends on the type of question. Now if you look at, you're talking about which quiz you're talking about, quiz or problem you're talking about. Let's go specific. I don't want to generalize that kind of stuff. Which quiz problem you're based on? Your question?
I think like assignment 2.
Assignment what?
Assignment 2.
Let's take a look at assignment. Assignment what? Which one?
2, Q2. Or,
To A or B?
either one.
Either
They're both
one.
the same, but one's SI and the other's US.
Okay. So what is your question then? By looking at it.
If we get an example like that like this on the exam, are we allowed to just use like the P is equal to T2 over T1 to the negative, or do you want us to derive the equation when we?
In this case, what do you think?
Just use the equation.
I don't think well, this problem doesn't tell you, hey, derive the equation to begin with, so you probably need to be given equation if a program like this is given. I think you would expect, okay, here's the equation, blah, 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 and then this statement shows up. If so, you can pick up those equations and try to do something. Suppose if the problem says, okay, derive this equation starting from hydrostatic, you have to do it. Depends on the type of problem. Any other question? Go ahead.
Are you allowed to tell us, or would you be willing to tell us how many questions we should be looking at? Or should we just be
Haven't decided yet, but how many problems do you want to solve?
None, preferably, but.
It's whatever. I just want to
You say whatever.
It's gonna be fun. It'll be fun either way. We'll have a fun. We'll have a good time with it.
So I guess you're only given 50 minutes.
So I'd say
You can only do certain things. So I would say typically I give you like a 3 programs similar to one of those type of programs, depending on what type, I don't know. 3, and then each program may contain part A, part B, part C, part D, part E, I don't know. If it's like a 2 points each, kind of explain this, kind of. Have you ever seen that kind of program? Of course you've seen that.
Yeah, we've seen it.
Everything is based on, supposed to be you're working on a homework and quiz and everything by yourself. That's my assumption. If you're doing that, you have nothing to worry about. If you're not doing that, it's impossible to pass this class, of course. Bottom line is very simple. Don't worry anything about it. Just do your stuff. Of course, this is the I expect you doing everything by yourself, understand perfectly, compare against instructor solution and fix your mistakes, understand. That's minimum for you to survive. Am I answering my question, or am I just giving you like a preach?
I answered the question, it
Yeah.
did. I also added some advice to it, but it did answer the question.
Okay,
Thank you.
Good. Please don't hesitate, okay? I have a tendency to go for preaching. Please stop me sometimes. But I hope you feel very comfortable. In other words, if you're doing whatever you're supposed to be doing, you feel very comfortable. Because my exam is based entirely on something we talked about in class example, based on homework that you worked on it, or based on the quiz. It's essentially fluid mechanics, based on those things. Something fully explained, I hope. I even give all the solutions, post that online all the time. So I guess someone actually, I didn't look at those things. That's your problem. That's not mine.
Yeah.
Okay. So I hope you feel very comfortable. And then I'm thinking 3 problems typically, unless you want to solve more or best problems.
Please no.
Okay. You can request. Let's make it one problem only. Kind of thing.
Yes.
I can do that because it's easy to grade for me. If you know it, you get 100. If you don't know, you get 0. Go ahead.
It's just gonna be on module 1, unit 1, correct?
It covers up until the material I cover maybe Friday before the exam. It's gonna be covered. Yeah, typically.
So next class period.
Yeah, I guess so. Oh, that's next class.
Yeah.
Okay. So whatever the material we cover until Friday's class, which is this week.
A week
Yeah.
from today.
Well, next week is an exam. I didn't know that, but anyway, I have to create the exam. So whatever the material I cover up until Friday will be on the exam. Yeah. But most likely, like a last-minute coverage kind of thing, is, I hate this again, because you probably need some time to kind of do something and then make it internalize your skill. Then you want to be tested for this. Any other question? Again, I try to be reasonable from my own very selfish standpoint of what engineers should behave. If you want to play game with me, you most likely going to lose your game. In other words, okay, what is the question here? Oh, I'm going to bet on this problem. I'm going to memorize it. I don't know what it is, but I'm memorizing it. And then hit the all-nighter a day before, and then hopefully I can pass. Well, go ahead, try if you want to. Engineering is nothing like that. It will never work. I'm sorry. So it reveals whatever you've been doing up to this point on your exam. If you're not doing it much, I guess it's going to reveal. Okay. And then if you have a tendency to make a small mistakes in here and here, make sure you explain everything to me. If you don't get your mistakes, I'm not going to give you any partial. Suppose if you don't show me any value you plug into your equation, you don't even show me the units, and you don't even try to explain what you're doing, don't expect much partial credit. I guess those are the things I've been repeatedly telling you through the homework and quiz and other things. I hope you get that. Okay, so those are the accumulated things, either good or bad. It's going to show up on exam. Okay, hopefully you accumulate good stuff. Go ahead.
For the project.
Project. Let's talk about project. Any more question about exam?
Usually, how many points are the exam?
Exam is out of 100. 10 points each. So if I give you 3 problems, 30 points. But it's going to be scaled to whatever the percent. So everything is normalized to that percent. Contribution percent. So 130, whatever, it doesn't matter, right? Everything's normalized. This is aircraft. Everything is no dimensional. Question? question for project. Question for project. Let's take a look at project page, okay? So project. So did you form up your project team? Are you happy with your project team? Okay?
Yes.
I went too far. Okay. Yeah, so first question is, did you form up your project team and you're happy with it? If somebody is not happy, let's just fix it right here, right now. You belong to the team, everybody is, hopefully at this moment, and you know your teammate is. And then hopefully you already started to communicate. Set up like a team meeting time. Of course, you can share file using OneDrive, already shared, only for the teammates. No one else can access to it, right? So please start using OneDrive shared file folder. And also you can communicate using Microsoft Teams, email, whatever. So that's been done, I assume. And next step, what's your question?
I was gonna ask.
Yeah.
So, are we importing our files into P1 main file, and then you run it all from
P1 main is
or-
given, so you have to use it as it is.
Yeah. So, but what I'm asking is the stuff that we develop as a team.
Yeah.
How is it being integrated into yours?
It's a MATLAB M file. You can call M file within your M file, within your M file.
Okay, so then you're just gonna run that, and then within it.
So you have to start with p1 main.m. This is the file I provided for you, so you cannot touch it. You have to use it as is. So starting from there, if I run p1 main.m, it is going to automatically run everything you develop and get the job done. That's what you need to be doing. It's a MATLAB M file modular script. That's the strength of MATLAB. MATLAB is designed for group working using that module script. Right.
And so we are not allowed, therefore, to make any alterations to P1 main.
P1 main.m, if you modify it, I don't care because I'm going to use P1 main anyways when I grade your work. Okay, so better not to touch it. But if you touch it, I don't even care because I use my own stuff. I'm not going to use P1 main.m, you submit, I just erase it and quickly replace with mine here, then run it from there. That means instructor is going to only run this. I'm not going to even look at other .m files. If .m file doesn't run, you get zero. Okay? So you have to stick with it. You have to use it as it is. That's starting point. Okay? Anything else? Go ahead.
What was the due date
When do you want to turn it? The other sections people said, well, you know, we're probably not going to do anything until the fall break. And then I'm not going to probably do anything during the fall break. So that means when you come back after the fall break, let's talk about that due date. That's what the other sections people said. Do you agree or disagree? I don't know.
I agree.
You agree on that? Robot agrees.
Right now, a bunch of other classes are throwing projects at us at the same time.
Yeah.
Okay.
Like,
So
do
okay.
do
So
this week
for a
project.
moment, you really want to avoid the thinking of.
It's
Okay, that's fine. So when you come back from fall break, okay, and let's talk about
for phase one.
for phase one project. When do you want to time? Are you okay? Well, he's passed out. Anyway.
You're good.
Any other questions? Project. All right. So let's move on to that. Okay. Okay. Are you happy or
Relieved.
We have a structures exam the day we get back from break.
Well, we're not gonna do that. I mean, that's.
So that's gonna be
You should. Anyway. Okay.
We have a structures exam the day we get back from break.
Yeah.
I'm gonna have a fun break.
But make sure before you leave for spring break, you just take care of your team environment. Of course, you have to do that. So if necessary, you can communicate anytime with your teammate and then make sure you're sharing file, you can see each other kind of thing. You have to take care of those. Then you go take an exam and go to fall break, forget everything, then you come back and start working. Okay? All right.
adding more.
So today I'm gonna go back into old style. I got a piece of paper, printed out notes. I hate to do this, but let's do it. I really hate doing this. This is my ancient style. No one is using this nowadays kind of style. I really don't like it. But anyways, I forgot to bring my reference. So let's take a look at class example problem A42. This is where we start in last class, IDE. Okay. So a jet aircraft is cruising high speed, high subsonic, more than 0.3 Mach number at the 10 kilometer cruising altitude. At this moment, you basically say, okay, well, I'm not going to use Bernoulli's equation. This is way more than 0.3 Mach number. Density is a variable. So we are going to pick up a different equation, which is energy equation, compressible Bernoulli, and then using the airspeed measurement equation based off of it, which we covered in last class, then we use that to figure out. Okay? So now, same thing. A pressure measured is 5.5 times 10 to the 3 Newton per meter squared. Somebody please tell me, what kind of pressure is this? What's this pressure?
Dynamic.
This is called dynamic pressure. Yes, you said that. Somebody said, okay. I really want to hear you saying this is dynamic pressure. Yes, this is P0 minus P infinity. Pressure difference between center tube and the side pole. Okay. So this is the only information you are given. So here, information given is, wait a minute, I promised you to show you the master notes, right? Sorry about that. So this is master note. Sorry about that. So I'm going to show you master note. Okay. This page, yeah, here we go. So this is master note, okay? So I'm going to also use the whiteboard at the same time, but assuming if somebody's online, then that somebody can see at least my master note. Okay. Of course, I'm going to use this one too. So either way, you can watch this one or that one, either way. Same thing. I hate to say that. Same thing. So of course, P0 minus P infinity. This is Q infinity. Free stream dynamic pressure is sensed by pirostatic probe, which is given 5.5 times 10 to 3 Newton per meter square. This is, by the way, Pascal. Standard unit. So I'm going to use this value as it is. Now, you're going to pick up the, this is calibrated airspeed. Calibrated airspeed, if you remember, calibrated airspeed basically uses all standard suitable value of static pressure and density and static pressure here to calibrate the airspeed. So calibrated airspeed is, of course, you're going to use standard suitable value of PS. This is standard suitable 1.013 times 10 to the 5 Newton per meter square. Speed of sound is based on the temperature of standard suitable gamma TS. Now, if you look at the TS, it's like what? 218 something Kelvin, yeah. Or yeah, Kelvin is 218 something. Yeah, okay. Anyway, so you plug in that.
Yes, 288.15.
Okay, you guys know that. So using that, and then gamma is 1.4, that's constant 287. Of course, you plug it in and take a square root, you get 340.3 meter per second. Somehow, you are so, I don't know, afraid of speed of sound nowadays. Why? Because you went through that terrible what, quiz or something, requires speed of sound everywhere. Because unless you know the speed of sound, that is the temperature information, you can never find out the Mach number. That is one thing you learned from quizzes, I hope. So every time when you use either Bernoulli's equation, low speed, or energy equation for high speed, you need to double check with the Mach number. In order to check the Mach number, you need the temperature information. Okay, so anyways, this is a standard suitable density 1.225 kilogram per cubic meter, of course. Those are the values required for calibrated airspeed. Okay. Well, calibrated airspeed. Okay, here we go. So lowest here, PS here, lowest here. This is given. Now you can compute. Calibrated airspeed BC is equal to square root of 1 over rho s times 7 times ps bracket. This is P0 minus P infinity divided by PS plus 1. Something's wrong. Oh, another bracket here. Another bracket. 1 over 3.5 minus 1. And then another bracket. And why do I have one more bracket? I don't think I need this one, but anyway. Oh, this is calibrated airspeed. Important thing you have to remember: standard sea level density, standard sea level pressure, standard sea level pressure. Everything is standard sea level. And then, of course, you know this is not a true airspeed at all. It's just a calibrated airspeed. But you're going to compute this. If you plug in all of those values, you're going to get, as my master note says, 93.878 meter per second, pretty high speed. So you wanted to check the Mach number of this. Here's the question: what is the Mach number? Of course, 93.878 meter per second divided by speed of sound. Speed of sound of what? If you take the speed of sound of sea level, do you think it is? But it's just use it because that's the only speed of sound given, you know. This is going to give you 0.276. Then you go right. Huh? What's the problem? What's the problem? This is
at 0.
this is AS. Is this a sea level?
No.
What's your flight altitude?
10
Takes it off.
10,000 meters.
Obviously, speed of sound is obviously very different from here. So you're actually flying more than 0.3. You kind of started to suspect, and then you're not going to move on. Hey, let's pick up the Bernoulli and plug and check. You're not going to do that. Okay. Now, final exam may entice you to do such a thing, such a thing like, hey, you know, Bernoulli's equation, energy equation, both equations given pressure information, temperature information, both information given to you. Go ahead, choose one. Then you go like, oh, this is less than 0.3. Let's just use Bernoulli. Boom, 0 out of 10. And you'll find that could happen. Because without argument, you cannot just jump right into the conclusion. So this is misleading. Is this correct? No. Of course not. What kind of information is needed? Of course, you want to find out actual temperature. Because what is the question anyways here? A jet aircraft is cruising, okay? At the location of a pirostatic probe, this thing is measured, okay? What is the Mach number on that location? It's not free stream value or not the standard sea level value anyway. So this one is only calibrated. Pilot never trust this value. So next step. Next step. Remember ICET? Now we did I to C. So now we have a C is this value. Next is E. Okay, no, okay, E. And then to, okay. So let's move on to equivalent airspeed. Equivalent airspeed is, do you have an equation for that?
No, it's just
No.
straight to.
Just jump straight to it.
No. It's not here. Do we need to go for equivalent?
Doesn't say.
It doesn't say so. So we can bypass equivalent. But suppose if you go for equivalent airspeed, what kind of equation do you want to use? Let's take a look. So next step is usually, okay, instead of using pressure of sea level, those two, you're going to actually pick up the pressure altitude value. Plug in actual value here. It is going to be fairly closer to the true airspeed, but not quite. In other words, one big unknown is the density of air always. But without knowing density of air, you can say this is a equivalent airspeed. Now, there's a quick way to find out equivalent airspeed is basically pick up this value, multiply by F factor, get to equivalent. F factor can be found in somewhere. F factor is given. Yeah, this is F factor table. Here we go. Okay. Unfortunately, it's written in terms of knots. So you have to convert knots into meter per second. Then pick up, okay, so what's the pressure altitude? This is 10 kilometer, and then convert it to feet. And then pick up those value multiply, and you can get equivalent. Go ahead.
Is there an equation for F factor, or is it just?
F factor is based on the equation. This is quick and easy way to move from here to here.
Yeah, but is there a way that instead of doing all the conversions and looking at a chart, is there just an equation?
You can create another chart in SI unit. That's easier way, using the equation. So this is for pilots use, okay? Not engineers use. So anyways, I guess one thing you have to know is, okay, we are bypassing equivalent, but in order to get equivalent, you have to do this. Where? Somewhere. You are doing this, okay? Yeah, BE, okay? BE equals to always F times BC. You're going to get equivalent airspeed. Now, in this particular example problem, purposefully bypassing this process, this is the lowest value. Lowest conservative estimate. Okay. And then typically, airplane indicates this. So pilot's call is indicated. Because this value is typically indicated on airspeed instrumentation. This is the lowest possible value and then conservative estimate. Conservative means that you're using actual values here. In other words, DE equation. If you write it out, okay. This is still 1 over rho s, 7 times P infinity now. This is still the same, P0 minus P infinity. Now this is P infinity plus 1 to the power of inverse of 3.5 minus 1. Let's close the bracket and close bracket again. So you can get equivalent airspeed. Now in this particular home example problem, I basically bypass it. But you can of course find out equivalent airspeed either using this equation or multiply F factor. Either way. So F factor is essentially based on the equation. Right.
Which method is more accurate, using the equation or just going to the F factor?
It's basically the same thing. In other words, this F factor comes in difference between here. In other words, PS and P infinity. That's the F factor. So you need to know the pressure altitude. Okay. Also, you need to know actual value of VC. So those two information given, you can multiply by F factor to quickly get this. Now, you're an engineer, you can use this equation if you want to. That's fine. But in case of pilots, they're flying airplanes, so they want to have this because it's a chart. Okay, this multiplied by that gets you equivalent. Go ahead.
And then for the knots to meters per second, do you have like?
Again, let's not talk about knots. Let's wait until because this is for pilots. Pilot uses knots. Knots are not standard unit. You don't want to talk about it. Wait until flight mechanics or flight control. Of course, we can convert knots into feet per second. Feet per second standard. We stick with feet per second or meter per second. This is a nautical miles per hour. We don't want to talk about it in this class. So I'm just showing you because this is what the pilot does.
Yeah, I was just sort of like figuring out.
Let me walk you through that later, okay? Because I don't want to diverge the discussion. I want to avoid using knots in this class because it's not standard unit, but the pilots use that. There's a reason. This is not flight mechanics class. This is aerodynamics. That's why. But if you want to continue discussing about it, I'll be happy to. Okay. So just to send me text and asking the same question, I'll be happy to explain that to you. Any other question? Okay. So let's just go back to the program statement once again. So program statement says suppose if you know that outside air temperature over T through an independent measurement is minus 45 degrees C. What is the true airspeed? Can you get the true airspeed out of it? Yes, you can. So in other words, first of all, what kind of information you can get out of outside of temperature? Obviously, you can determine this, right? First of all, pressure altitude information gives you the pressure. Because 10 kilometers, this is the pressure altitude. So this is the standard pressure value at the 10 kilometer altitude. You can get that kind of information from your chart. If you have a chart in your hand, please double check. Okay, good. One person checking. How about the other people? Don't you bring the chart into the classroom? Or don't you bring your device? Basically, double check the device using device. Anyway, so this is supposed to be the standard value at 10 kilometer altitude. This means 10 kilometer pressure altitude. I'm not talking about 10 kilometer is an altitude, no. I'm talking about this is the pressure I'm sensing. Based off of that information, you are probably flying 10 kilometers. That's the meaning of pressure altitude 10 kilometers. So this information is given from the altitude information, which is based on the pressure measurement. And then this is outside air temperature. Those two combined, you can get real density, right? Now you are going to use the true airspeed equation. Now, true airspeed equation is based on the equivalent. You are going to multiply the density ratio inside of here. That's the only thing. Because now you know the real density. Instead of standard sea level density, you use that to get the true airspeed. Okay. So equation-wise, this is basically so this is rho s over rho infinity. 1 over rho s. The rest is the same equation. So basically, you introduce this thing, density ratio, into the equation. Okay, that's the only difference. So instead of standard sea level value of density, you're going to actually use the actual density of your flight altitude, 10 kilometers, and then you're going to compute through airspeed, which is 159.243 meter per second. Okay. This is true airspeed. Now, once you get the true airspeed, you probably want to check the Mach number. Mach number based on A infinity. Well, how do you get this A infinity? Well, you're going to get temperature at the 10 kilometer standard value, assuming that you are flying 10 kilometer and then today is a standard day. We never know this though. But assuming that, actually,
Temperature is given.
temperature is given.
Yes.
Yeah, okay. So temperature is given. That means you can get the actual airspeed, speed of sound. Okay? If this information is given, well, guess what? You can actually get the real Mach number of your flight. This is something what you want. This is way more than 0.3. Okay. So this is the computation checking process you really need to go through all the time. Now, suppose if I choose this kind of problem for exam, if you don't check the Mach number, I'm not going to give you 4 points. You have to check the Mach number. Usually, I state in a problem statement saying, check your Mach number. Then if you don't check it, you lose points, of course. Okay. And then percent error between calibrated airspeed to the true airspeed is 41%. But think about that. You're flying 10 kilometer altitude using standard sea level density. 41% difference is not so bad. But 41% error is pretty bad. So that means the pilots, typically, they are aware always saying, airplane indicates, especially like a Cessna 172, airplane indicates this much airspeed. But they are aware almost always that, hey, this is estimate, conservative estimate. I will most likely be flying much faster than that, and I can figure it out if necessary. That's the flight computer. Okay.
That's between the calibrated airspeed and
Yeah.
true airspeed, right?
Yeah.
Would the equivalent airspeed
Yeah.
be a lot closer just because?
In other words, yeah, that's right. From here to here, much more closer. So it's gonna be probably, I don't know, what's percent? I don't know, maybe 10-ish%.
Okay.
Right.
So the outside air temperature tells you T infinity from the problem
That's
statement.
right.
Okay, and then you got rho infinity from ideal gas law,
That's right.
and then that requires you to have P infinity, which you got from a table, I'm guessing?
This is from altimeter. In other words, your altimeter is based on the pressure sensing.
Okay.
So you sense the pressure of this value and then go back to the standard property table, 10 kilometer standard value.
Okay, so you did pull that from a table.
That's right. So 10 kilometer pressure altitude is not the 10 kilometer altitude.
It's the pressure at 10 kilometers.
Pressure is happen to be the standard value of 10 kilometers. So you probably guess that you're probably flying 10 kilometers.
Okay,
That's
so
what the pressure altitude is.
if this question were on, say, an exam, would we be given a table that corresponds to different pressure altitudes?
I guess so,
Finding
yeah.
that value?
I have to give you that kind of information because I'm not going to ask you to memorize the table. No, of course. I don't even memorize them.
Okay, got it.
Of course, yes.
If we weren't given the temperature, could we
Yeah.
assume that the temperature in the table is right if we're given the pressure altitude?
No, this temperature is, again, static temperature is very difficult to measure anyway.
Yes.
Yeah, so this is outside air temperature. Somehow you got it from some other source.
Okay.
That's the only thing I can tell.
Okay.
Yeah. Okay, good. Very good discussion. Those are the important things. So next page, I want to conclude unit A4. So people say less than 0.3 is incompressible. Why is that? This is going to basically solve the question. Let's begin with one of those equations we derived in last class, based on, what is this equation anyway? Did you get this equation?
Yes.
We derived the three equations in last class, starting from energy equation, isentropic flow, and calorically perfect ideal gas. Now, under those assumptions, you get three equations. One is T0 over T infinity. The other one is P0 over P infinity. The third one is rho 0 over rho infinity. Those are the range of temperature, pressure, density between free stream to the stagnation point. Let me go back to the figure here. I hope I retain the figure. I don't, no, because this is master note, that's why. Okay. I can't draw it. Okay. Let me draw it here. So this is the figure I did in last class. Okay. This is a pirostatic probe. And you're going to draw a bunch of streamlines. Sorry, this is not captured in video. This is the free stream. This is the stagnation point 0. This is, again, free stream infinity, static port. Yeah. So we can get those three equations in last class. This is a high speed more than 0.3 Mach number. So those are the three equations you see. Okay. So this is the temperature ratio between free stream and then stagnation point. This is the pressure ratio between free stream and stagnation point. And then free stream is the airspeed you're flying. And then obviously free stream Mach number is the Mach number your airplane is flying. Okay. So this is pretty much like the lowest possible value of pressure, density, temperature, because this is essentially air. Yeah? Atmospheric value of pressure, temperature, density for a given altitude you're flying. Right here is a stagnation point, actually gives you total values, P0, T0, rho 0. Those are probably highest possible value of pressure, temperature, density. In other words, within the flow field given, this is how much change you can expect on temperature, pressure, and density, which is function of only one thing. What is it? Mach number. That is the equation I want to kind of pick up with. So let's just take a look at this equation. Okay. This is the density variation within a given flow field, which is a function of Mach number only. So let's say if the Mach number is 0.3, how much variation of density you can expect? Let's take a look at that last page. That's what this plot is. So Mach number 0.3, what is the change of density within the flow field? 5% or less. Okay. So my conclusion is if the flow field is simply external flow, okay, isentropic flow field, more than 0.3 Mach number, well, yeah, it's compressible zone, incompressible. In other words, cutting off is 5% change of density within the flow field. So let's ignore 5% change of density. That's the meaning of incompressible subsonic flow regime. That's why people use 0.3. So if the 5% error is too much for you, you shouldn't even use that 0.3 or less is incompressible subsonic. It depends on the type of flow field you are dealing with. Now, some of the applications of the airplane, 5% error is not acceptable. If so, you shouldn't be using casually, the noise equation. Okay. So there's always reason why we call this incompressible subsonic. Okay. So next time when you casually sit together with airplane pilots at the flight line and eat lunch together, you can say like, oh, less than 0.3 Mach number is incompressible subsonic, right? And then, oh, of course we know that. Then you can say, do you know why? Oh, because. Take a look at this equation. This is equation, well, coming from like a compressible version of Bernoulli's equation, isentropic flow field, and then calorically perfect ideal gas within this equation, range of change of temperature, range of changing density is less than 5%. That's why we call this is incompressible subsonic. Please try that. Then see what they say. Okay? They're pretty good, actually. They may know better than this. But at least you should know that. Okay? Any question here, concluding A4. So that means exam, I don't think I'm going to include any A5s. So focus on unit A1 to A4. That's going to be next exam 1. Okay? So let me repeat. Exam 1, I'm going to create the program, 3 of them, coming from A1, A2, A3. Okay? 50 minutes, cross-book notes. Very, very, very similar to something we discussed in class, or you did as a homework or quiz. So please go back and compare all your solution against my solution. Fix your errors and mistakes and misunderstandings. Okay, that should be perfect to prepare for the exam. All right, so, okay.
Since you only grade some of the homework problems,
Yeah.
What do you want us to do to compare our solutions for homework problems that were not graded?
Yeah, so I guess you have to compare one at a time, I guess.
Are the solutions for the homework problems you did not grade still up on the website?
Yes, everything.
Okay.
Everything.
Yeah.
So, yeah, go ahead. Question.
Yes, so if we are doing unit conversions,
Yeah.
I know I had a sheet, or we're doing unit conversions, will we be given like help with unit conversions, like remembering that one unit kilograms equal
Okay. So unit conversions, those are the kind of thing I have to give it to you. I'm not expecting you to memorize all of them.
Okay.
Of course, like how many newtons a kilogram force, stuff like that.
That's what I was
of course.
okay.
I give it to you.
On the exam, can we expect, or can there be any problem, part of a problem where it's like a word answer, where it's like, what does inches of water mean? Explain how it is, like on the homeworks.
Do you like that kind of problem? Or you
Not
don't like it?
particularly, but it doesn't matter what I like.
Okay. Not sure because I haven't created yet, but possibly. But possibly means that unless I ask that kind of question in homework, I mean, I cannot create that kind of problem anyways.
Right.
So suppose if one of the homework assignments included that kind of question, you need to be ready for it.
Okay.
Okay.
Which one was it? Like this kind of thing? Yeah.
Yeah.
Yeah, this kind of.
Yeah, exactly.
Yeah. So So those are the explanation examples. I may pick up some of those. I don't know. Any other question? All right. Solution is all positive. So please double check your work before exam. Okay. All right. That's it. So see you guys on Friday.
Some people get us since we looked at credit class.